Hello and welcome to Unit 2, Part 4. Today we're going to talk about evaluating to see if points satisfy a system, and then we're going to solve some systems and then we'll kind of review some graphing of slope-intercept form. In previous lessons we've talked about setting up systems of equations, and a system, remember, was just more than one equation, and for the most part we're going to be talking about two equations in Algebra 1. Well, in this case, we're going to determine if the values provided are solutions to the system. A solution to a system has to make both of the equations true. So I should be able to plug in the x for x and the y for y into both of the equations, and they both make true statements. If one of them does not, then it is not a solution to the system. So let's start plugging in on number 1 and see if 2, 1 is a system to that particular system. So I'm going to put a parentheses everywhere there's a variable for the first part. And in place of the y, I'm going to plug in the y value, which is a 1. And in place of the x, I'm going to plug in an x value. In this case, I get 1 is equal to 6 times 2, which is 12. 12 minus 11 is 1. That particular equation, the point worked out, but it's got to work for the other one also. So let's set up the other one with the open parentheses. And now I'm going to plug in my x in place of x, which is a 2, my y value in place of the y, which is a 1, and let's work this out. Negative 2 times 2 is negative 4. Negative 4 minus 3 times 1 makes negative 4 minus 3, which gives you a negative 7, and that is equal to negative 7, so it is also true. So 2, 1 is a solution to this system. Same concept for question number 2 here. The first equation says 2 times x minus 3 times y is equal to negative 1. And now I'm going to take the x value, plug it in for the x spot, and the y value, plug it into the y spot, and see if it makes true equation. So the x is a 3, and the y is a 4. In this case, I get 2 times 3, which is 6, and negative 3 times 4 is negative 12. Is equal to negative 1, and 6 minus 12 is negative 6, which does not equal negative 1. So there's no need to even test the other equation. It didn't work in the first one. 3, 4 is not a solution to that particular system. Now let's test the point for number 3. So we have y is equal to 5 times x minus 7 from the first equation up here. And the x value is a 2, and the y value is a 3. And let's see if this works out. 3 is equal to 10 minus 7, which gives me 3 equals 3, and that is true. Now we have to plug it into the second one. I'm going to slide over here to the left where I have more room. Negative 3 times x minus 2 times y is equal to negative 12. In place of the x, I'm going to plug in the 2. And in place of the y, I'm going to plug in the 3. And let's see. Negative 3 times 2 is negative 6. Negative 2 times 3 is negative 6. And negative 6 minus 6 is negative 12. So this equation is true. Yes, 2, 3 is a solution to that system. Now we're going to talk about how to solve a system, and there are several different methods. And we're going to start by talking about how to solve a system of equations by graphing. The way you do that is you may need to rearrange the equation and put them both in slope-intercept form. That way you can graph it like we've been practicing. And the solution to a system is where the two equations intersect. The one point that they touch at is the solution to the system. So let's just start. So where it says the first one over here, y equals 3x minus 4, we can go ahead and plot that one. The y-intercept is a negative 4. The slope is 3, so up 1, 2, up 3 over 1, up 3 over 1, up 3 over 1. So it's not easy to draw a good straight line on my iPad, but I'll try my best. And now the second one you may notice is not in slope-intercept form. So I need to put it in slope-intercept form. I need to make it look like my first equation did. Well, all I need to do that is to move this minus 3 by adding 3 to both sides. Now it is in slope-intercept form, and I can graph it. A y-intercept of 3. A slope of down 1, right 2, down 1, right 2. Or, from my initial point, up 1 and left 2 is the same concept. And then when I plot, or when I graph that line as straight as I can on my iPad, The place where they intersect is right here. You've got to find the coordinates of that point, which is right 2 and up 2. So the coordinates of that solution, that point, is 2, 2. Looks like we kind of lucked out on the next example. They are both already in slope-intercept form, so I don't have to do any rearranging. Let's start with the top one. Has a y-intercept of 2. Has a slope of -2, which is down 2 and to the right 1, down 2 and right 1, down 2 and right 1. Or from my starting point, up 2 and left 1. It still lands on the same line. I'm going to try my best to draw a good straight line through those points. And the second one has a y-intercept, a b value of -2. And it also has a slope of down 2, right 1, down 2 and right 1, or up 2 and left 1. And if I draw a straight line through that one, you'll notice that these two lines do not intersect each other. Well, that means there is no solution to this system of equations. They never cross. They do not have an x and y value in common with each other. Last example, we can go ahead and graph the top line. It says y equals 3x minus 3. The y-intercept is a -3. That's the point where we start. Slope is +3. Remember, is up 3 and over 1, because that 3 is understood to be 3 over 1. Up 3 over 1, up 3 over 1, or down 3 and left 1. So I'm going to try my best to draw a good straight line through those points. And the last one is not in slope-intercept form. I need to put it in slope-intercept form. I can do that by just moving the x term to the right, giving me y equals -3 plus 3x. They're not like terms, so I'm going to put my x terms first, which is the +3x, and then bring down the -3. Now it can be graphed. Now if you notice this one, the y-intercept is -3. Let me change the color. Is -3, and it's also up 3 over 1, up 3 over 1. So this line and the first line, they land on top of each other. What that means is this particular system has infinite many solutions. That means they have every single point in value, every single x and y, every single point in common to this particular system. They wind up being the exact same line. All right, thanks for watching and hope this helps.